today I've got a Sony STR AV570 and it doesn't work. And the reason it doesn't work, well, for one, I don't know what else is wrong with it, but one of the things that's wrong with this thing here is a child had a temper tantrum, say that 5 times in a row, and decided to get angry with the buttons, and they buggered up the buttons. So we have switches that are stuck here. I don't know whether the circuit board behind it is damaged or not yet. I'm just in the process of dismantling the unit. This is an integrated amplifier. Uses a linear power supply, conventional power transformer. This is an IC output, an STK4192, I should say. It's a stereo amplifier IC. That would be probably, they would rate at around 40 watts, although I'd say good luck getting 40 watts out of that thing, but that's probably what this thing was rated when it was new. So I'm just going to pull the front off. I've already taken the screws out so that I can remove the front cabinet, and we're going to disconnect the interconnect cables here that connect the main board to the front control board. So we'll just shove the camera over a bit here. So we're just going to disconnect these 3 connectors so that I can separate the control board from the rest of the amplifier. We can just push this thing aside for now. Oh, a screw fell out of there. What do you know? I got to take the board out because my switches are on the back side of this board, so I got to remove all the screws here. And it may just be a simple matter of, I don't see the board broken, so that's a good sign. Just have to realign the plastic clips and put it back in shape, and we'll give this amplifier a general servicing. One of the big problems that goes wrong with these amplifiers that use these big power ICs is that solder connections quite often break on the bottom and they cause an intermittent condition, and that may be why, in the first place, why this thing ended up in the shape that it's in. We may have had a frustrated user that the thing was going into protection or doing something, and they got mad and they overreacted, let's say. You know how teenagers are, right? If you ever had a teenager, you'll know what I'm talking about. So we'll just remove all the screws here and take a look at the board and realign those switches, and then we'll proceed to give the amplifier a once over and see if we can save the patient. I'm pretty confident that we'll be able to save the patient here and keep another piece of equipment out of the landfill. Even though this piece of equipment is not going back to its original owner, this piece of equipment is going to find a new life here in my workshop. And I've already started the process here. I've gone and put myself a nice little shelf here. I'm going to put that amplifier right up here next to my monitor. And I've even put a secondary shelf in for my speaker. I got one speaker up there and I got one speaker here on the other shelf beside my workbench. So once I get this unit going, I'm going to have some a nice little test amplifier here, all courtesy of an angry teenager, or I should say the angry teen's parents that gave me this unit. They said, hey, you can have it, and if you can fix it, you can have it. So that's what we're going to do today. We're going to fix this unit. So I've got the switches out. I don't see anything broken on the circuit board here. I just see the switches are malaligned, so we just take the switch assembly out. It should just lift out. Actually, I might not even have to do that. I might just be able to realign them without doing anything like that. Looks like the switches aren't damaged. Looks like there's no broken plastic. They just were out of alignment, and I can now just reseat the circuit board again, and at least this problem should be solved. There we go. Now our switches should work. Oh, video is sticking still. We'll see why that one last switch is stuck. Maybe that's got it. Here we go. All the switches are now working. We'll put all the screws back in, and we'll start by reassembling at least the face, and then I'll get into the base on this thing and take a look at the connections on the relay here, and take a look at the connections mainly in this power IC, because those are the ones that give us the most problem on this type of design. And it was an ongoing problem when I was in the business. I would replace lots of those ICs for sure. They do fail, but they also develop solder connections that go bad, and will cause the unit to shut down. Usually if somebody gets on it right away, they can save the IC. Other times, depending on which pin goes bad, you can lose one of the voltages and it can actually cause the IC to fail. But we won't know about that until we get around to powering it up, which I'm going to be doing shortly. I'm just going to shut the camera off here momentarily while I put the screws back in here. We'll pick this up in a minute. Okay, we've got all the screws back in to the front board. We're just going to take the unit and slide it back into place. So we'll just get the supporting feet underneath the chassis, and it should just, and this little circuit board here has got to go above the chassis. Slide the feet in below the chassis and line it up, and it should just snap together like that. Got a couple screws to go on the top here and a few more on the bottom. We'll attach them now to keep the unit together, and then reattach the interconnect cables, and then we'll go into the bottom of it and inspect for bad solder connections. So we got a couple screws in here to hold the front on. Turn the unit over, and we got a couple more screws that go in the bottom to hold it together. You know, earlier today I decided I would go out and get myself some lunch, because I don't normally go out and eat during the week, so I kind of treat myself on the weekend. And one of the places I usually go to is a place that's in the next town over, and they have an electric car charging station there, so I can charge up my car while I'm grabbing my lunch. And today I pulled in there, and to my delight, I couldn't get a charge because there was two other people on the charging stations. It's, you know, it's something you don't see a lot of. But there certainly is a few people driving electric cars around. I saw another Chevy Volt, which is what I drive, so I don't have to worry about being stranded. I can just go revert to gas if I run out of charge, which I didn't have to because I had enough to get home. But there was a Chevy Volt on one of the charging stations, and I saw my first Ford Focus electric today, and it's a nice looking car. I've never seen the electric one before, but there was an electric one parked right next to me today. I think that's the first one that I've seen on the road. I see Teslas everywhere, and I really don't understand why I see so many Teslas everywhere, because a friend of mine's got a Tesla, and I tell you, once you get over the wow factor of the 17-inch touchscreen on the thing, it's really not that great a car. I mean, yeah, it's got a lot of power, but it's missing a lot of, you know, pretty standard features that you think you'd find on a car of that kind of price. Like just things, little things like a lighted vanity mirror. You know, I mean, my Volt's got a lighted vanity mirror. You flip down the visor, open up the vanity mirror, and there's a light on either side. And my friend's Tesla, nope, doesn't have that. And the fit and finish on it, for what that thing costs, I don't think was that great of a car. So once you get over the touchscreen, which I got over that the first time I saw it, because when my friend took me out for a drive in it, he just about crashed it because he was trying to figure out how to turn the volume up or down on the radio, how to adjust the temperature, and he was playing around with his giant iPod in the middle of the dash when he should have been driving. And then he's showing me, hey, look, I can send an email while I'm driving, and he's sitting doing this. So that didn't really impress me, but. Anyway, we got the front controls connected again. We're now going to take a look, and it's going to be tough to see on camera. I'm going to have to move the camera for you to see it. Connections I'm interested in looking at are right here, so I'm just going to take a quick peek at them. Well, the power IC connections look okay, but the ones I'm concerned about are these ones here, are these regulators. They look really bad. Looking at them with the magnifying glass here, there's cracked solder. I can see it. It looks kind of silvery, like a dry connection. This one here looks also to have some, looks like somebody's tried to reflow these things in the past, but it doesn't look to be very good. So we're going to redo these. These are the regulators, low voltage regulators. So certainly if you have a problem with the low voltage regulator, they can cause a problem. Another big problem on these amplifiers that I just spotted, I'm just going to show you this one here. This is a very common problem on these Sonys here. This is a grounding tab here that grounds the board to the chassis. And someone's tried to resolder this thing here, but I bet you I can just break this off. If I get a pair of pliers in here, I bet you this is just gonna break right off. Look at that, yeah, that's a good job. That's a good job of trying to fix the ground. So somebody in the past had tried to solder the ground wire. What Sony uses is they usually use screws and they tighten them down, but they go loose. And one of the well-known fixes on these in the past was to actually put some solder on and get it to stick to the chassis. But the problem is solder doesn't like to stick to a steel chassis. But that was a common one that I used to see quite often. And basically what you got to do is you got to tighten these damn ground screws down as tight as you can get them. That one's really loose. But these ground screws have to be tightened down on both sides here, on both sides of this heat sink. There's one there, and there's another one. I got to put the screw back in because I took it out to remove the chassis, and it grounds the front board with this little ground wire here. So we have to put this ground wire back in and tighten it down good, because this provides your main ground. This is probably what went wrong with this thing and why it was cutting out, was because the ground wires came loose, the chassis ground. So we tighten that down so it's good and tight. That grounds the front board to the main board to the chassis. And there's another grounding screw back here that also needs to be made sure it's tight. It's got like a copper washer that's soldered down to the board. But this is another chassis ground right back there that you need to make sure is tight. Any of those grounds that come loose, it's also a good idea just to torque down them all, just to make sure that they're snug, because one of the biggest common problems on these units where the complaint is it goes into protection mode. You're listening to it and it just shuts down. You know, you got the radio playing and it just goes off. Either goes to protection, it'll come up with like a, it'll either say it'll either say protection on the screen, or it'll be a little red P or something, and the sound cuts out. And the biggest cause of that is ground screws that are loose, as well as these regulator transistors down here. Both this one that's on the heatsink and this other one here, the solder connections crack. Especially on this one because it does not have a heatsink. This one's a heat sunk transistor because it's a transistor or regulator. I think it's just a transistor on this one. What is it? Let me see what it is here. Yeah, this is just a transistor. 2SD2012. So they're not using a. Sometimes they'll use a 3-terminal regulator to give you your 12 volt or your 5 volt supply. This one here, they got a Zener diode somewhere in there as a reference, and that's just a regulator transistor, as is this one here. But they solder connections crack on them, and you'll have a problem. And this one here, as I say, this receiver here looks like somebody. Well, I know someone's tried to fix this, because this was a fix that was floating around for years. I saw this one years and years ago when I was in the business. People would try to solder the board. They'd try to solder the copper traces on the board here to the chassis, rather than just tighten down the screw. And yeah, that was a known issue. You can't really solder very well to a steel. Steel is not a good receptor of lead and tin. They don't bond very good. They will flow well to copper, but they won't solder to aluminum, and they won't solder to steel. The chassis is made out of steel. I'm just waiting for my iron to warm up to get nice and hot, and we're going to reflow these connections here, and then we're going to test this unit out. Okay, we're ready to solder these down here. I'm going to use my new magnifying glass that I got from Canadian Tire with my Canadian Tire money for free. Of course, that's only applicable to those who live in Canada who know what Canadian Tire is, but it's a big retailer that handles automotive and other goods and stuff, and when you buy stuff, you get like a rebate money. And I'm always getting stuff for free from them. So we're going to resolder this one, get it good and warm to make sure that there's no oxidation still on the actual pin itself. We'll zoom this thing in so you can see what I'm working on. That little filter looks like it's cracked too, so we'll do that one. And we'll just do the Zener diode here. As I said, I thought it was a Zener diode regulated, and there it is. There's the Zener right there. So that gives us our reference. So we'll make sure that one's good and soldered in. Same with this cap here. This one looks like it's a bit flaky. And then we'll just redo this transistor. And this cap here might even be leaking a bit. It kind of looks like there's kind of a bit of green gunge. You see this? It looks like there's kind of a bit of green gunge on the board. So this one even might be leaky. I'm just going to take a look at that one and see if it's bad. We'll change it while we've got it apart. It's a small 47 at 50 volts is what it looks like it is. Let's just pull it and take a look. This one just with this green gunge that's kind of looks like it's leaking out of it onto the board here. Where was that one now? Kind of looked like something had been leaking onto the board there, just from the look of it. But looking at the cap, I don't see anything leaking out of the actual capacitor itself. But we've got it out of the circuit, so I'm just going to take a look at it. If it's even anywhere near questionable, we'll just replace it, because I've got it apart now. We might as well do it all at once, right? So this thing's 47. Did I say at 50 volts? Yes, 47 at 50 volts. Should be about between 0.56 and 0.68. 0.39. I think we're okay. We're fine on that one. And just because I'm lazy today, I don't feel like putting it back on the bottom, on the top side of the board, so I'm just going to solder it back in here on the bottom side of the board for where it came out of. Because we have lots of room here. It's not like it's going to touch anything. The cover's going to go on here, no problem. Okay, now we'll put the cover plate back on. Wherever I did with that. It's right here. If you look at the design of these cover plates, you'll find that it's all stamped from one piece of metal. And when they stamp it, they basically take the piece that they've cut out of it and they turn it around, and it fits. It fits where they've cut it out. So if I take this piece here, you'll notice if I turn this thing around like that, that's what they cut out. That's what they stamped out, you see? Just a way of recycling and saving metal. They cut out one piece, they turn it around, they form tabs into the bottom of it here, and that holds this side in, and that becomes your bottom plate. It was very ingenious. Sony and a few other companies did this. Fortunately, a few other companies like, let's just say Yamaha was one. Some of the Techniques ones were another. They didn't get that. They didn't put a nice servicing plate on the bottom to make it easy for a technician who had to work on it to take the thing apart. I used to dread those machines like the plague. You get a Yamaha and then you got to do something to it. You got to spend an hour taking the board out. You had to lift the entire board out. Same with some of the Techniques ones. You had to lift the entire board out to get at a component to resolder it because it had overheated. And then when you're telling the customer, well, the labor is $125, and they're like, what do you mean? Well, it's, you know, the design of this thing was you got to pull the whole circuit board out. And, you know, had you bought a different brand, you could pop the bottom cover off the thing and be done in 15 minutes. But this one takes an hour because you got to pull the board out to get at it. not a smart design. If their engineer had spent a few more minutes on the design of the cabinet, they could have done exactly the same thing that Sony, and not only Sony, many companies did this, but Sony were very good at this. Could have used the same type of design as this, and it would have saved the service people a lot of time. I'd get a Sony in, and it was always a breeze to work on because they were a well-designed unit. So now I'm going to hook up my speakers to this, and I'm going to do something, because this is going to be my test amplifier for my bench. The purpose of this is so that when I want to test another amplifier, I don't have to disconnect my speakers. So I'm going to tie my speakers together with my bench speakers. So because the grounds are already common together, so I can tie the two grounds together on this and it won't hurt it. So I'm going to tie my black wire and my red wire to my right side speaker and connect that down to the right speaker terminal on the amplifier. And I'm going to do the same thing for the left speaker. What this will allow me to do is, well, one, I can play music from here, but if I want to, well, that didn't go together very good, did it? If I want to test another amplifier on my bench, I can just flip the speakers off on this, and that'll open the relay. And then I can utilize the speakers without having to physically disconnect the wires. Say this is not cooperating, this wire here is kind of thick. We'll just trim it down a bit. And yes, I'm fully aware if I hook it up to another amplifier under test and I don't have the speaker switch turned off on here, I'm fully aware that I could blow both this amplifier and the one under test. So no one needs to remind me that. This unit has to be either turned off completely or the speaker switch has to be off. Grounds don't matter because they're all grounded together anyway. So, and anything I'm testing, any piece of equipment that I'm going to likely to have under test on my bench, it's going to be plugged into an isolation transformer anyway, so it's not going to make any difference at all. Okay, now that our speakers are connected, before I put the top on, we'll make sure that this end of the wire that nothing is touching, because these ones are going to have the speaker signals on them as well. We'll just plug this unit in, power on. Make sure everything's turned down. And speakers are on. We have sound. Cool. This thing's nice. It's got a phono input too. You can select all my nice vacuum fluorescent display. Tuner, CD input, tape input. It's even got a video input, so it's got two auxiliaries and tuner. So there we go. We've completed it. We've fixed the problem. We fixed the problem. It was a bad ground that was causing this thing to not work. And then, of course, it was an over-anxious child that was upset that the stereo wasn't working and took it out by trying to put their foot through the front of it. Anyway, I hope you enjoyed this quick video on the repairing a Sony STR AV570. I'll add to my collection of stuff on the wall. So I got this for free. I've now got this for free. I did have to buy the speakers. I've had them for 20 odd years and they're PSB, made in Canada, great little speakers. And I got this for free. That was given to me as well years ago. The reason this one's all held together with tape is because, well, the cabinet's all broken, it got dropped, and the circuit board was smashed inside it, and I had to jumper about 20 connections to make it work. And it's held together with packing tape. But hey, it works. And it was free. Gotta like that. Now I have music while I'm working. courtesy of my own private FM radio station. What that is I've got one of these MP3 players that they used to sell that you could plug your SD video or SD card into, and it would play through your car radio. And I just added an external input and connected it up to my satellite dish, and I can pipe music around the house. It has a range of about, I guess, about 100 feet. I put an external antenna on the thing, and it has a range of about 100 feet, but it gets the job done. Sounds great. And here we go. I've got music in my workshop now. Well, there you go. Hope you enjoyed this video, and we'll see you in the next one. That's the little unit that's transmitting my music from my satellite dish. As you can see, it was originally designed to plug into a cigarette lighter, and I just kind of put my own wires on here so that I could connect it into my satellite receiver, which is down here, which is an old Motorola DSR 905 Digicipher receiver connected to an old 10-foot satellite dish, and it pulls in the music choice channels.